This was an old Army depot base.
Well, I was at CCC,
and it got decommissioned, and so now there's a lot of industrial manufacturing facilities. The California Air Resources Board also has a facility here, I think, for enforcement and air monitoring. But there's a lot of industry that's moved into this place to kind of keep it moving. Siemens, and then the California Mobility Center is at the far end.
Nice.
It also houses like smaller organizations like the Sacramento Tree Foundation, and then so large and small.
So what does the California Mobility Center do?
The California Mobility Center is supposed to be a public-private academic consortium to stimulate or catalyze industry and tech and innovation. The focuses are supposed to be like academics, mobility, education, and medical. And so it's an opportunity where private industry, like let's say Siemens or BMW, can come in and do some research and do some work here, like let's say on batteries or innovative mobility, but then also can partner with the schools and the engineering groups to be able to provide the students an opportunity and to break through science and technology.
Awesome.
Yeah. Power generation also, but on the policy side, the capital, Sacramento, we want to use it to push innovative tech throughout all the state as a form of a policy driver. If something gets, then you can push it out and into the other communities.
Nice, nice. Having an event?
Yeah, I think they're having the event that Moira was talking about. They did, yeah.
As soon as the lowrider's done, every event they have, we'll bring it over and park it.
Yeah.
Oh, okay.
Drive it right up that ramp, make it happen.
So the original concept of this ray is from the University of Aachen in Germany. There you have BMW, you have different auto manufacturers, Ford. Also there, this is Ash. Dalal.
What's up, Ash? Frey Leon.
And so the original concept was out of the University of Aachen, with PEM Motion. Now PEM Motion now lives here, right? PEM USA.
Yeah, they have a branch in Sacramento, and I think they have, it's Arizona or some other state.
But in Aachen, you have people like Ford, Siemens, BMW, Audi, a lot of auto manufacturers that are working with the university to innovate transportation and mobility, right? So they look at everything from autos to transit buses to people movers. So even like something that you like a scooter or something like that, right, that you can do. But
bicycles, I see bikes in the background.
Right. But it was really a way so that if you're Ford or BMW and you're having an issue with battery density in EVs, you could bring the university and all the other partners together to find a solution, a common solution, to break through battery technology. Once you find a solution, you can share it with all the partners that are a part of that consortium and project. Sometimes if Ford or BMW says, well, I don't want the partners working on this, I only want the university working on this, then you can reserve the patent and only use that technology for Ford or BMW or whatever. But really, it's supposed to be used as a consortium for problem solving for everybody.
Communal,
yeah.
Nice,
and then shared out. So the battery from BMW that came out, it's very well known. That was developed there and shared out by a lot of the manufacturers.
Wow.
The Ford Lightning was developed there, and the Mach-E was also developed.
Wow,
there.
that's awesome.
So now we see it in real life. Right
yeah. That's awesome.
Give us kind of a stepping stone. So Ali and I have the test bench where you press the pedal and motor spins with the batteries on display there, and that's basically half of them. So we have half of them in Danville right now. These are the other half. And then
there's our batteries.
Yeah. So we do have
those in the bottom.
It's just yeah. So if we did decide to do that, we have that as an option. But once I get an idea of when those batteries are actually going to be delivered, then we can kind of maybe gauge and see what all that happens.
3, 4, 5, 6, 7, 8, 9, 10.
Wow.
So it's $5,000 per battery?
Not those. How much were these, Ash?
Cost-wise,
Yeah.
these were actually brand new units that were originally on a Honda EV in Europe, and they were, I'd like to say, about 200 of each module. So that equates to about let's see, kilowatt. Trying to do my math right now. It's about almost $100 or $50 to $100 a kilowatt hour. So pretty sizably low compared to what is on the market. But these were already manufactured for automotive purposes, and so the performance of them was kind of exactly what we were looking for. So this particular vehicle, of course, isn't just moving, but it's also powering a stereo. It's also powering all the fun stuff, hydraulics and things. And so when you put all those loads on, the normal car battery would do it, but not very well and not very long and not very safely. These ones were able to at least provide that opportunity to do so much more robustly. So these were really kind of the only things on the market that could handle it. But the form factor wasn't ideal, but that's
So
where.
what's the difference in the specs from the new batteries that we just got a hold of to increase the range?
Yeah, so the new batteries that we're getting are actually more in line with what's used on, like, let's say, probably like a Tesla more like. So these are like rectangular little blocks that are about 12 of them in each one of these little modules here. The Tesla form factor are like the cylindrical style, like you plug in with your remote control on your TV or something. Just a little bit different size canister, but those are a little bit more energy dense. They can hold a lot more capacity, and they can also deliver a lot more current. So the form factor of those, let's say these right now, it's about 20 kilowatt hours. We can condense all of that into probably 4 of these boxes. So
all of those into
this
4
whole
of those.
entire assembly into just 4 of these.
Oh, nice.
So that's where we are now able to leverage that new technology. And as Maury and I were just talking about, this just came out in October. So we're evolving just as quickly as they are. And so unfortunately, when we were originally putting these things together, what was it, back in February of this year, even before that, nothing was on the market. So the big heavy hitters on the market right now are like SEMA, the big automotive aftermarket show. They're really kind of displaying all this stuff, and they were really the only candidates out there that had a drop-in solution that you can purchase, in these kind of configurable form factors. And so the one that we're purchasing is in this shape, but they do have ones that are a little bit smaller, a little bit bigger for additional capacity as well.
Nice, nice.
But
all right.
yeah, so we actually have the motor and everything to show what the differences are. So we actually have another motor for another project that is at my software guy's house in Danville, so we're still in the process of communicating with, but this is really kind of a good visual of the compare and contrast. And so this was the original 327 V8 that was in the lowrider. That was, I think, not the high-end motor, but the one below that only gave about 160 horses and what was it, 10 miles per gallon, if that, so not so efficient, but with an automatic transmission, it was good enough for the day, but not as good in terms of performance in comparison to some of the newer vehicles. So, and then of course, with the fuel mileage the way it is, not the greatest for efficiency, and if you don't want to stand behind it and smell all those fumes. But so in case, what we're replacing it with is this motor right here, and this is from a company called Cascadia Motion, and they are actually one of the only suppliers that are producing automotive grade motor solutions for aftermarket conversions and things. And so they're a very low volume manufacturer that is a spawn off from Borg Warner, which is a large transmission company that builds heavy duty truck transmissions and car transmissions for Ford and GM. So they have a lot of those design principles in place. But this motor in particular is about 310 horses and about 450 foot-pounds of torque. Right, so about 4 of those in here.
Wow.
And
amazing.
No fumes in the back. So
and no pollution, no killing kids.
Yeah, but it poses a different design challenge where we don't need a transmission in this case, but because of the fact that this produces all of that power on the instant, we now have to retool the rear end, the gear ratios, and all sorts of stuff. And so we're mating it to a single fixed drive axle ratio, as well as a gear rate reduction over here. And that would give us the performance that we need, but at least get us in line to accelerate and keep a whole a 50 to 60 mile an hour speed on the freeway. So it seems like there's a little bit more involved there, and that is also one of the things that we're trying to convey in this new curriculum too. Is It's not just the motor that we're putting in; there's all the parts behind it that are all part of the sequence here.
Nice, nice.
This is just one part of the ingredient list.
That's beautiful.
Yeah, so this is kind of a cool visual here to see, yesterday and today. And as much as we've evolved,
Yesterday century.
yeah. It's funny now, like my wife works at UC Davis, and I guess we're all considered born in the 1900s. It's like, what am I, just riding to work with my wagon and my horse? Like, so this is 1900s technology, and this is 2000s technology, I guess is the more hipster way of saying things.
Yeah.
So, but yeah, so we originally had the chassis and vehicle over here, and since it is now back in Sava's hands, we're going to still do some of the bench testing over here as we get further along on the software side. My software guy is in Danville, unfortunately, so I figured it'd be easier to keep everything over there. But as we get further along there and migrate some of the stuff back over here, we should see more of the test bench with the batteries and the motor and everything fairly soon here. But it still gives us an opportunity to.
It's a great visual.
Yeah, I love this. It's just real simple. In fact, when there's an opportunity, I'm going to coordinate with Galen to get this back over there and maybe just have the students or ourselves build a little quick engines test stand or something, and we can just have them on display there to show.
I think that'd be great.
We definitely want to.
That's going to be for the museum right there.
Yeah, right. I mean, it's really kind of a spectacle, but the complexities and in the last 100 years of gasoline engine development, what have we gotten? Like maybe 1 or 2% better, and so 10 miles per gallon in the 60s has gotten us, 20 miles per gallon now in 2000? So, we really haven't done much, and physics and Mother Nature aren't going to give us any more to play with. So that's where now the industry's realized
they're going to give us some, but we're not going to like it.
Well, I mean, dinosaurs are still going to pollute, and
they're going to give us heat waves. They're going to give us, bad air days.
I'd rather not have sub-zero, winters in California, over 100 degrees in the summertime. So as much as we'd like the thrill and the sounds and the smells, it's just not going to be good if I want to retain some form of health, in past 2020, 25 here. So
what would be interesting if it is in the museum? Like, these are super new. You're not going to see this alongside it because it'll be in action in the vehicle, making a mold of it.
Get a 3D.
Making a mold of it.
Yeah.
And where it's just like,
Yeah, and so that's actually right behind you. There's another kind of avenue that we're doing here at the CMC is kind of showing off some of the new manufacturing methods. So,
the 3D printers.
Laser cutting, yeah.
Which one is that one? Which one are those?
Those are units from a company called Ender. They're
that's the one we got.
Yeah, they're great. I mean, they're $200, $300.
Yeah.
I just bought one myself. That was a lot more, and I'm figuring out what am I paying for here? It's real different. But yeah, I mean, for students and really just to get on the ground and to do something, these you can't beat the price and value.
Yeah.
But we've had really good success with folks to not only get their imagination going and coming up with the project, but to learn the process. How to do design, how to actually design for manufacturing. And then accompanying that are the laser cutters too, which are able to.
Let's go check them out.
Yeah, absolutely. So we just had a group come through over the weekend, and they're kind of doing some individual projects here. But and
the students from Sava come out here and do stuff.
We can. I think that's where we're hopefully going to bridge that relationship here, and then also hopefully get the new facility up to speed with some of this latest equipment. So hopefully I can be on the guiding end of that to support what their new focus is, but also get them more familiar with what's out there that's new. So again, this is kind of an example of some of the fun stuff that students are doing.
This one thinks it's printing that out.
Well, yeah, so that's again one of the challenges with this is you have to watch the process initially to make sure everything's going. Like this thing, I don't know what's going on here, but apparently
the filament is not even going
it's
through.
Not even going through. So again, that's where I think that's where you get what you pay for sometimes,
right.
So like the bed flatness, the material, the temperature of the bed are all kind of important. I know the more you pay, the less you have to do of that scrutiny, that work there. But still, these are great tools to at least show the process and the software and everything else involved. And so, but the laser cutters are also great tools, and we have a lot of cool projects that are coming up. We had some guy do a Tesla Cybertruck here. A bunch of cool little trinkets and things to just, again, show more of the process. But if I take an idea, now I have to put it to a point where I have to assemble it. So how do I design for assembling? Meaning I have to put a notch here, I have to put a cut here, I have to do something else outside of that to make it all come together. It just doesn't happen. So that again gives that perspective to students to, work with each other to kind of understand what they're dealing with, but also understand what their end game is. What am I trying to build here? Just a trinket or actually something that's working?
I see you have some technology products over here.
Yeah, so, alongside the manufacturing, there's still the base theory that can easily be taught using some of the basics that are readily off the shelf. I mean, you can buy these Amazon kits for $20, $30, if not cheaper. But this is the same motor that you see over there. It's the same batteries that you see on the tray over there, just smaller, right? So as a demonstration tool, I don't have to lug around, a 100-pound battery or a 300-pound motor. I can just run this little guy. So one of the other kind of cool things that we show off is, if you have a second, I can show you real quick.
Go.
Is my main kind of hobby, but also one tool that I leverage in a lot of these training is radio control cars. And these are exactly what we are driving. This is exactly the technology that we see, on the road here. And so these are great demonstration tools, but again, compact enough where not just one group of students can have one car. Each student can have its own car. So we're able to show them, from a viewpoint of electric vehicles, this is the same lithium battery, this is the same brushless motor. The controls are all pretty much the same in terms of battery management, how to throttle, how to do steering, how to do all these things that our new regular cars that we drive to work, are now scaled down to a 24th scale, and again, are great tools. And so we're using a lot of this to not only show the EV hardware, but get students more involved with an environment that is a little more collaborative. So if I were to work with somebody on an engineering front to create an assembly of some sort, one of the tasks that we had with this was give this same car, we have 30 of these kits, everybody has the same car here, take one part of it apart, write the procedure that you did to take it apart, and then don't put your name on that instruction list, but give it to somebody else. And if they can interpret that and do that, you're successful, right? If you haven't, then that's a bridge for communication there to say, well, what did I do wrong? What am I communicating? So from my perspective as an engineer,
or how did I misinterpret it? Or
well, we always have that stigma, especially in engineering, is those are the shop guys. We don't have to talk to them. But the same thing, the shop guys, like those are the engineers. We never talk to them. Right. Every time I used to go out to the shop floor, they're like, "What are you doing here?" I'm like, I'm working with you. Like I need to, my job gets easier if your job gets easier, right? So that way you don't have to come back to me and I don't have to come back to you. So if I get this sorted out first, we cut time, we cut resources, but you have more confidence, I have more confidence, and we can get about our ways. But in this case, we teach students not only the basic principles and theory of the vehicle itself, but now we're engaging them to work with others on assembly procedures, and how to communicate, how to talk about that, how to write things down. One of the cohorts that we had come through here were political refugees, where English wasn't their first language. So we had to break that barrier by not only giving them something to apply towards, but engaging them. Like if you don't have that opportunity to talk, to communicate, to make those eye contacts, you really don't have effective training. I can give you all the tools and resources, but if you can't go out there and use it, what good is it? So this gives us a good avenue to do that. So, yeah, we've been really successful with these, and they're only like $100, and so low-hanging fruit.
Nice. That's badass.
And I get to write off all mine. So yeah, we're just showing the
awesome breakdown.
Training.
Passion. I can see that passion in the brother.
Yep.
While we're here, can I offer anybody any drinks, any water?
Yeah, I'll take a Modelo.
Yeah.
Yeah. Nah, I'm good.
I think you got 12 o'clock.